Kinematics Example 11. In this example, we're moving away from horizontal motion and starting to look at vertical motion. In this example, a ball is projected vertically upwards from a point O, so that would perhaps be on horizontal ground, with a speed of 12. We've got to find the greatest height that the ball reaches. So if you imagine throwing a ball up into the air, eventually it will come to instantaneous rest and then it will start to fall back down towards the ground. Now, we've got to be a little bit careful with direction here because the ball is being projected upwards, but as we know, acceleration due to gravity will be acting downwards. So you've got to make a decision about which way you're taking as positive. I tend to take upwards as positive when I'm doing a question like this. So if we think what we've got, the initial speed was 12. At the point where it comes to instantaneous rest in the air, we have a final velocity of 0. This means that the acceleration is minus 9.8. It's going in the opposite direction to motion. And in part A, we're asked to find the greatest height. So it's the height at which this particle comes to instantaneous rest. So that's what we're looking for. Looking at that equation, I think we're going to use v squared equals u squared plus 2as. Substituting in the numbers, v is 0, so when you square it, you also get 0. 12 squared is 144. And then we've got 2 times a times s, which is what we don't know. Okay, so if we rearrange that, we'll get that s is minus 144, taking that over to the left, divided by 2 times minus 9.8. Just by rearranging the algebra. And if you work that out, it works out to be 7.346. It's an ongoing decimal. Save it in your calculator in case we need it later. But if we're going to round it off, I would round it to 2 significant figures. Now, the reason I do that is because the value that we used for gravity, we did to 2 significant figures. If we'd used a more accurate value than that, we could have given a more accurate answer. But if this is accurate gravity to 2SF, you can't give an answer better than 2SF, really. Okay, part B, we've got to find the total time before this ball returns to O, the starting point. So if you imagine you've thrown the ball up, it comes to instantaneous rest. And because it's vertical, it will come right back down to the starting point. We know that when it gets back to the starting point, its displacement S is 0. We've got to remember that S is displacement from the starting point. We know that U is 12, that was the initial speed. The acceleration is still in the opposite direction to motion. If U is upwards, acceleration is downwards, it's the opposite direction. And we've got to find T. Okay, T is what we're looking for. Looking at these, I think one identity shouts out at us. Hopefully you spotted that one. And it's going to be another one of those, I think, where we're going to get a quadratic because T is the thing that we're looking for. So S is 0, UT is 12T, half of A is 4.9 and it's going to be minus 4.9 because the acceleration is minus 9.8. And then we've got t squared. So that is a quadratic equation. It doesn't have a constant term, so it's one of those where you can just take the t out in order to factorize it. Okay, so 2 solutions here. You've either got t is 0, which is obvious, the displacement was 0 at the starting point, or 12 minus 4.9t equals 0. Rearranging that, we get t equals 12 divided by 4.9. And if you work that out, it comes out to be 2.448. Again, it's a long decimal. And so if we round it to 2SF, it will be 2.4 seconds.